Consider the following problem. At this point, we could solve this problem using augmented matrices. The first, our augmented matrix, would be 5, 3, 2. And our second, we could do it again. We would go through our Gauss-Jordan elimination, and we could do it again for this third. But we see this becomes a little tedious, especially if system A is staying the same each time. In each of our augmented matrices, this beginning part is the same each time. So then the question becomes, is there any more efficient way to solve a problem like this? For the algebra of numbers, solving a system that looks like 5x equals 15, we would divide both sides by 5 to get that x equals 5. The question here, is there an analog for matrices such that we can go straight to what x is? To do this, we need to generalize a notion of matrix division, and we'll do so with multiplicative inverses. For numbers, this looks like 1 over the original quantity. And we have the property that n times 1 over n equals 1. For matrices, first note, not every matrix will have an inverse, but we'll reference it with this -1 superscript, and we'll have the property that a matrix times its inverse is I, where this I is the identity matrix. The identity matrix is a square matrix, and it has 1s along the diagonal and 0s everywhere else. In that earlier problem, if we can find the inverse of A, we can use that to easily solve these various systems. Where we only need to perform matrix multiplication. Our next question would be, do all matrices have inverses? The answer is no. If our matrix is not square, then it's not invertible, meaning it has no inverse. Secondly, if its determinant is 0, then it has no inverse. We say that a matrix is singular if it has no inverse. In this class, we'll only be interested in calculating the determinant for a 2x2 system. If our matrix has the form A, B, C, D, then we'll say that the determinant of M is AD minus BC. As an example, the determinant of 1, 2, 3, 4 is 4 minus 6, which equals -2. Note that if the determinant of a matrix is non-zero, then it will have an inverse. This means that the matrix 1, 2, 3, 4 does have an inverse.